All right, I'm back. We're going to be doing section 10.5, which is back to multiplying. Hope you're doing all well, by the way. I know this is kind of a crazy time we're living in, and you know, if you have any issues or needs or concerns or prayer requests that you have, feel free to put those in an email to me, and or put them on the discussion board, whatever. Maybe we can all pray for each other, maintain things through all this. But section 10.5 goes back to some multiplying of radical expressions, and it's a lot of it has to do with foiling. If we have x plus y times say 2x plus y, we FOIL this and get 2x squared. Foiling the first outers, we have plus xy. Inners, we have plus 2xy. And last, we have y squared. We have these four terms, and a lot of times these four terms will all simplify together. Maybe it'll be a 2x squared plus 3xy plus the y squared. Well, if we have this with radical expressions, then things can end up looking well. Sometimes some interesting things can happen. For instance, let's say we've got 3 plus the square root of 7 times 4 minus the square root of about 11. Well, to FOIL this, we've got the 3 times the 4 is a 12. 3 times a minus square root of 11 is minus 3 square roots of 11. Here, square root of 7 times 4 is positive 4 square roots of 7. And a positive times a negative minus square root of 7 times square root of 11 is square root of 77. And it looks like actually none of these things can combine together. This doesn't get simplified. The only factors of 77 are 7 and 11. But that's how you would multiply these things. But occasionally it doesn't work that way. Sometimes kind of interesting things happen. Take a look at this example. Let's do back to this 3 plus the square root of 7. This time, let's multiply by 3 minus the square root of 7. And going into this, you may remember this as being a plus b times a minus b factoring pattern type thing, the difference of two squares. Watch what happens. I'm going to FOIL this. 3 times 3 is 9. 3 times a minus square root of 7 is minus 3 square roots of 7. Square root of 7 times 3 is a plus 3 square roots of 7. And positive times a negative is a negative. Square root of 7 times square root of 7 is square root of 49. Square root of 49 actually is 7. But look at these right here. The minus 3 square roots of 7 and the positive 3 square roots of 7, they cancel. And we're left with 9 minus 7, which is 2. That's pretty neat. This completely cancels, all the square root stuff just cancels away. And that's because these are called radical conjugates. Radical conjugates are binomials with radicals that are exactly the same, except that the middle sign, one is positive, one is negative. That's pretty neat. And the way we can use that is, what if we are dividing these? Go back to the rationalizing of the denominator. What happens if I have 6 divided by 2 plus the square root of 5? Well, this is not simplified because there is a square root in the denominator. How do I get rid of that? Well, in the previous lesson, what I did is I multiplied top and bottom by something that would make this cancel out. But if I multiply this by the square root of 5 over the square root of 5, what happens is the square root of 5 distributes to both of these. I have 2 square roots of 5 plus the square root of 25, which works great here, but I still have a square root in the denominator. So I have 2 square roots of 5 plus 5, and all this did is just get more complicated. So obviously that's not the best way for this to work. So there is a better way, and that involves using the radical conjugate. What happens if I multiply both top and bottom by, instead of square root of 5, or instead of 2 plus square root of 5, then what if I have 2 minus the square root of 5 in both the numerator and the denominator? And what's going to happen, and I'm kind of out of room here, so I'm going to go down here. In the numerator, I've got 6 times 2 minus the square root of 5. I didn't distribute that yet for reasons that you'll see in a moment. And in the denominator, I've got 2 times 2 is 4. 2 times minus square root of 5 is minus 2 square roots of 5. Square root of 5 times 2 is plus 2 square roots of 5. And square root of 5 times square root of 5 is minus square root of 25. That's 6 times 2 minus square root of 5. The 4, these cancel. The square root of 25 is 5. That's 4 minus 5. 6 times 2 square roots of 5 divided by negative 1. Now I'm going to distribute this through. And the reason I didn't yet is if this had been a 2 or a 3 or a 6, it could have reduced with that 6 there. So instead I'm going to let this negative go up with the 6. This is going to be a negative 6 times 2 minus square root of 5. Distributing gives negative 12 plus 6 square roots of 5. And that ends up being my final answer. So that's how you can multiply binomials with radicals and allow that radical conjugate kind of trick to make our square root go away in the denominator. All right, that's it for this lesson. We'll see you in section 6.